It's like Baby Huey. All right.
Hello.
Hello. Shalom. You know what's funny because someone from my first hour was watching the video, and with the subtitles on, and YouTube subtitles, it automatically does it. It actually said all those. It says konnichiwa, and it says shalom, and it actually like, you're like, man, I've been wondering how to spell that, and then it came up. All right. I'm like, whoa, that's pretty interesting. All right, arc length, surface area of a solid revolution. So now we're actually just trying to figure out the area of that solid that we have. So we had this solid, whatever shape it was, and now we just want the surface area, what was on top. Okay, arc length's easy. Okay, so find this, blah. Okay, length of the arc. Here it is. So arc length is going to be S is going to be like the nomenclature for that one. So it's S is going to be my arc length on this from A to B, my whatever points on the x-axis, and it's going to be the square root of 1 plus the derivative of the function squared. That's important. Okay, that's very important right there in that formula. It's the derivative of the function squared. All right, so let's write this one. So arc length. So arc length from 0, pi over 4, square root of 1. Come on, brain work. Brain. Plus the derivative of the function. So to take the derivative, I would have to chain rule that, right? Say yes.
Yeah.
Okay, what's the derivative of secant? It's secant tan? Secant x, tangent x, right? Okay. Times, okay, what's the derivative of ln? 1 over x, but in this case, my x is going to be secant x, right? Okay, so now that one's going to work out nice and pretty because what's going to happen on my secants? Cancel, so I get, now it's going to be tangent of x squared and dx. Yes? Anyone recognize that for something?
It's a property with this secant square.
Is it?
Yep. I just searched it up yesterday.
You just cinched up yesterday?
Well, it was for homework.
Oh, wrong one. I'm not denying it. I'm just making sure.
It's denied.
Okay, so that one's going to be secant.
I was looking at the other.
Now, you guys remember those little cards, those flashcards I gave you guys? Stuff like this is on there. I need you guys knowing these things. Keep going over this over and over again because they will come up. And it makes a whole lot of difference if you already know this. So, integration of secant x. What's the integration of secant?
Maybe 1 over cosine. And then integrate. Well, we're.
Come on, you guys.
That's a different way.
Can you do it like 1 over cosine and then just integrate that? Cause
I don't know.
secant That was such a wise laugh.
How is it wise?
Yeah? Okay, so,
Yo. Yeah.
okay, so we can go through and actually do the identities, like, try to figure them out if you don't know these off the top of your head. I keep pointing stuff out. We can go through and actually eventually come up to this using different identities. So basically, I need sine somehow to be in terms of cosine, right? Okay, I need sine somehow to be in terms of cosine. So I could say sine squared plus cosine squared x equals 1. There's a identity there, right? So I don't want sine, right? So I wanted to say cosine, so it's going to be sine squared x equals 1 minus cosine squared x. So sine of x is equal to plus or minus square root of 1 minus cosine squared x. So where there was a sine, or could be a sine, I could replace it with that. But I know that my cosines are supposed to go to be equal to u, right? So you guys can go through with what you do know and eventually come up to the right answer. So, integration of secant came out to be what? ln? ln of what? What'd you have? Yeah.
Secant x plus tan x.
And that's going to be from 0 to pi over 4. So there is a whole lot of work involved to eventually come up to be the right answer over there. By figuring this part out, it's you know, I could come up with that, or I could just go through, make sure I memorize those flashcards for these certain things. All right, so let's go ahead and plug it in. So what is secant at pi over 4? Okay, first, think about pi over 4. Where's pi over 4? That's the x value, right? So it should be rad 2 over 2, but now flip it over. 2 over rad 2, right? Okay, 2 over rad 2, rationalize, which just gives me ln of rad 2, right? Yes? Okay, good. All right, so now, tangent at pi over 4. 1, because it's the x and the y, right? X and y, so it's going to be plus 1. Okay? And my lower bound, secant at 0. What is secant at 0? Think about 0. 1, right?
Yeah.
the cosine, so it's gonna be 1. What's tangent at 0? Tangent is the y over x, right?
So it's 0.
Yes, it is gonna be 0. So it's gonna be plus 0. What is ln of 1?
0.
Yes, that does come out to be just 0. Okay, the second half is gonna come out to be just 0. So my answer is gonna be ln of rad 2 plus 1. Yes, no, maybe? Do we want decimals for that? Say no. Okay,
Well, I'll give it to you.
you're going to?
0.881.
Okay. What that guy said. Alright. So, didn't we used 2 things in this problem that should be on your flashcards about things that you should know. We should know that this is secant x right here, right? So I could replace this hot mess with just secant x. And then when I took the derivative, I need to know when I take the integration of that, I have to know that. I can go through and eventually come up with the answer of what it should be and what it simplifies out to be. It's just gonna take you a long time. Those flashcards. Okay. Here it is right here. That was my answer. And the length of that cord would be, what was the?
881.
0.881. So the length of that would be 0.881 of that function. Find the length of the graph of the function here from 1 to 8. What's the derivative? The derivative of x to the 2/3.
It's 3x to the 5/3 over 5.
When I take the derivative, what do I do with my exponent?
Wait, did I say?
You did
Did I like integrate it?
Yeah, that was really weird.
Oops, my bad.
Nobody questioned her, so I was like, does that
That's
mean
why everyone was so quiet. I was like, wait, what the heck?
Yeah, I was like, hey, have I been deriving?
Like, you should just.
I the one that's incorrect.
Whoops, my bad, sorry.
No worries.
How off would you
Thursday,
be to
my
the integral of it?
Very.
Oh.
That's for 89 versus 90%.
That's true, pretty much.
That's you. That's you.
We're ready?
Yeah, we are.
Okay, so square it. Right?
X to the negative 2. Wait, no, let's not say anything.
Well, yeah, negative 2/3.
Can't you take the square root of the entire thing?
No.
Why not?
Because it's adding.
You have 1 and you also have the square root.
But you're adding.
Yeah.
You're like, forget that one. Just disregard that plus sign right there.
You square root that too.
Just square it.
It's for the plus 2.
It's obviously 1.
Throw a minus on there.
plus times.
Well, it is a minus. This is.
Yeah.
Hey, that works.
No, it
Does
didn't.
we just
Yeah.
changed- just
Oh
changed
my
the
god.
course of
Y'all,
this.
y'all thought.
Plug in the 2.
Y'all
and
give
then-
me.
Yeah, every time you guys do that, the kitten dies. So please don't do that.
That's so far.
All right,
It's been a good.
do the math.
Just take the 2 And
So
put
it's
it
going to
in
be
parentheses.
4 over 9, that's a 9, x to the,
2/3.
right? Common denominator?
9/9.
All of that on the bottom, right? So it's going to be, right? It would be 9 x 2/3 plus 4 all over 9 x to the 2/3.
Now just take this.
Yeah, that's what I was gonna say.
This is gonna be
Boy.
9x 1/3 plus 2.
Okay,
Yeah.
so
You just get rid of that.
can we break this up?
Rat over rat. It's today, not our day. Mm. Wholesome.
Now can I do that?
Only to the bottom.
Only to the bottom. That's gonna help me out. If I could at least clean up that much.
Yikes. 9x to the 1/3.
So I get so when I take the square root, actually I'll rewrite it again. Right? So what's the square root of 9?
3.
Plus one.
And that's gonna be okay. Alright, so that cleans it up a lot. So now, to do that, what don't I like here?
The top.
The top, the radical, right?
Yeah.
Can I use sub for that whole radical?
Sure.
Yeah. Alright, so let's take care of that. So it's gonna be u equals 9x 2/3 plus 4 du is going to be, what's that gonna be?
2 over.
Right?
Yeah.
Okay, so again, I have that x, right? So all this is going to be u to the 1/2 over what? 4 x 1/3. Oh, crap, come on. Times right? And this is du now, right? All right, so now I gotta try and figure out what x is gonna be, right? I'm gonna try and figure out what x is gonna be. So I'm gonna sub part of this. So it's gonna be u equals 9x 2/3 plus 4. U minus 4 equals 9x 2/3 divided by 9. So x to the 2/3 is equal to u minus 4 divided by 9. So when I multiply this, it's gonna end up becoming u to the 2/3, right? Say yes.
Yeah.
It's gonna be u to the 2/3 because 1/3 times 1/3 is 2/3, right?
Yeah.
And that's why I left it in the 2/3 format. So right there, so when I do this, it's u 1/2 over 12 x to the 2/3 du, and I'm going to replace that with my u minus 4 over 9. So it's going to be u 1/2 over 12 times u minus 4 divided by 9, and this is du, and this is still my integration. So I'm still getting to the point where I could simplify this to be able to get it. Did I kill everyone here? Everyone just died. Thought I just saw someone pull out a sword and like about ready to commit Senbukku.
Not yet. Not yet.
Are we lost or we okay?
Are you okay?
Yes.
Yeah.
So,
Yeah,
what do you
it's
use?
killing you too.
Shouldn't it be 6 instead of 4?
It's making them all.
When I use subbed here
Drive.
and take the derivative, because when you take it and take the derivative, it's over 3. It's 2/3, right? So 3 times 2 is 6. You're right. Dang it. Okay.
Damn.
But that's not really going to affect too much.
Do it again.
Yeah, it's just going to.
Go back.
Just
No. The reason why I say that is because I actually haven't done anything with that 4 except write it down. Or, yeah, so it's going to be right here, then here. Oh, crap. You're right, I did. I multiplied it over there.
Shouldn't also be divided by 4.
No, it's not. No, it's not. I'm just kidding. Okay,
Shouldn't it be du?
I guess that's
over
right.
six? Actually, 1/3?
Yeah, that's what I had all wrapped.
Yeah.
I was like, oh, okay, just went away.
all right, listen.
Yeah,
Listen. Listen, Linda. All right.
On every homework.
Okay, I'm gonna go back and fix this one. I'm gonna send out the video for this when I fix it. I'm gonna fix it right after this because we're running out of time right now. So I'll fix it. You guys know I'm not gonna be here tomorrow, right?
What are we doing tomorrow?
Wrestling?
Yeah. Okay, I have wrestling tomorrow. So I will fix this next hour. Then I will send out the video. Okay. Sorry, I will finish it.
Where did you